Okay, so the question here is going to be to do with using the product moment correlation coefficient. So from the large data set, the daily mean wind speed W knots and the daily mean gust G knots were recorded for the first 10 days in September in Herne in 1987, and we've got our data down there. So first of all, just make sure we know the difference between wind speed and gust. So wind speed, mean wind speed, is like the average wind speed for the day. It's kind of averaging out how windy it's been. Whereas a gust, that's when if you're walking along and you feel like a gust of wind, it just kind of captures you. And so that's like a moment, an instant, and so they're recording the maximum gust when we're talking about G. Okay, so the data's there, and then there's a few questions we're going to answer to do with this. So first of all, state the meaning of NA in the table. So NA just means that the data's not available, because for some days in the large data set there isn't data available, and so therefore that's just what that means. And part B, calculate the product moment correlation coefficient for the remaining 8 days. So calculating a product moment correlation coefficient is just using calculators and using the correct mode. So we don't really need to actually calculate anything in a normal kind of way. So if I bring my calculator around, hopefully you can see this. So we're going to go to menu. We need to go to stats mode. So option 6. When we're talking about correlation and regression, we're talking about y equals a plus bx. So we need to select option 2. And then we come up with a table. So frequency might be on or off. It doesn't actually matter here, because the columns we're interested in are x and y. If you've got frequency on, as I have, just ignore it and just leave a load of ones in there as you fill the table in. So x is going to be the W, which is the mean wind speed. G is going to be the maximum gust. So I'm going to start filling those in. So 4, 4, 8, 7, 12, 12, 3, 4. Oops, I need to get rid of some of these actually. And so I've started filling in all the X columns, but when we get to ones that I've got NAs on, so over here, we obviously have to miss out the X's as well. Because the whole point about this is that it's paired data, and so the 4 and the 7, they're not actually paired with any data there. So there's only actually 8 days where we've got pairs of data for, so I just need to get rid of the 4 that I've just put into my table here, and replace that with the 10 that goes at the end. Okay, so now I've got 8 days that I have data for to put in. So notice that's different to if we were dealing with something to do with rainfall. It said trace TR. So NA just means the data's not available, so we're going to have to just ignore that. If we see trace when we're dealing with a large data set, we want to do some kind of calculation, we replace it with a 0, because trace means that there was almost no rainfall. It's just that there's a little bit, so that's different to saying 0. So in the data set it gets recorded as something different, but from the purpose of making calculations, you should treat it as a 0. Okay, so I'm filled in the X column. I then need to do the same for the Y column. So we go back to the top and start filling those in. So 13, 12, etc. Okay, so we've got a table filled in. As I said, I'm not bothered about the frequency column. It doesn't actually matter if you've got it on or not in this instance. And then to get the product moment correlation coefficient, it's option. We're doing a regression calculation, so option 4 here. And then it's coming up with various numbers. Hopefully you can see that. So the one that we're interested in is R, because that's the product moment correlation coefficient. So it's 0.9533 if I round that to 4 significant figures. So you don't actually need to be able to calculate a regression line, but that's what A and B are actually telling you. So if you look at the top, it says y equals a plus bx. So that would be telling us that the regression line is y equals 1.85 plus 2.59x. But as I said, you don't actually need to be able to calculate that anyway. You can vote. It's pretty simple using the calculator. Okay, so that's done. And the final part of the question is just asking us, with reference to our answer to part B, comment on the suitability of a linear regression model for these data. So we would say that it is very suitable, and the reason for that is that we've got a correlation coefficient that is very close to 1, and so that's suggesting a very positive correlation. And what we really mean is that there is a strong linear association between the mean wind speed and the maximum daily gust, and so therefore linear regression model would be suitable.